we're going to take this idea, we're going to apply it on to how to add and subtract. Because right now, we're probably pretty good at finding LCD. Done a lot of that. We're pretty good at finding equivalent expressions. Done a lot of that now. We're going to combine those ideas with addition and subtraction and see that we can add and subtract some fractions that don't automatically have common denominators given to us. So let's look at how to do that. So we're going to add and we're going to subtract some fractions. That don't initially have common denominators. For instance, it's like 3/4 plus 1/6. You know, when I first introduced the concept of adding fractions, we had a pizza party. You guys remember the pizza party, right?
Yeah.
Yeah. Did you buy your pumpkins yet? And
Yeah.
Did you really?
Yeah, I bought it from my daughter.
Oh, I carved a black sheep and carved a pumpkin. I just watched someone carve pumpkins. That's pretty much the same thing. The other day, it was kind of fun. Maybe we'll carve one day. It's a huge pumpkin. The Merced College had actually a pumpkin patch thing. Pretty big pumpkins. Anyway, moving on. If we did a pizza party, and I said, if you had a pizza, and it's sliced up into 8 slices, and you had 3 slices here and 2 slices here, together you had 5 out of 8 slices. If we try to do the same idea here, you'd have a pizza that's cut into how many slices here?
6.
This one.
4.
And this pizza would be cut into 6 slices. Here's the question. Say you're really hungry one day, or these are mini pizzas. They're pretty small. And you eat 3 of these slices, and 1 of these slices. How much pizza have you had? Have you had 4 slices? Yes. Yes, you've had 4 slices. However, you're talking about different size pieces, aren't you?
Yeah.
These 4 pieces are bigger than these 6 pieces. So if I'm talking about adding this pizza together, I can't say I had 4 out of 4. I didn't. Because this piece wouldn't fill up that piece. Does that make sense?
Yeah.
I can't say I've had 4 out of 6. Because these pieces are bigger than these 6 pieces over here. I can't do that unless I convert this to the same number of slices. And here's how you do that. Pictorially, like as a picture, what you would do is cut these pizzas again to make sure they had the same number of slices. In our case, that's probably going to be 12 if you look for LCD. So I'd go, okay, here's 4. I want to make more slices here. Here's 6. I want to make more slices here. So everywhere I would cut this, so it has 12 slices. Here, I'd have to cut a little bit more. Now, if I filled this in, that was this whole region. And that was these 2 regions now. Do you see the difference in the picture? Can you see how now I could add up 1, 2, 3, 4, 5, 6, 7, 8, 9 out of the 12, and 2 out of the 12. If we have 12 slices now, I can directly add those pieces together. Are you with me on this? The 9 12s plus a 2, that should be, what was that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We should have 11 out of 12 slices on this when we're all said and done with this problem. That's how, as a picture, we can represent adding these fractions together. You just have to make new slices. Now, the new slices, that's the idea of finding a common denominator, and that's why we have to use what we just learned in order to do this problem. Did the picture thing make sense to you?
Yes.
Good, okay. You guys are tired today. Don't give me the excuse it's Monday. I'm here too. Come on. I had a weekend, just like everyone else. I just drink more coffee than you. Perhaps. here's the way we're going to go ahead and add these fractions. The first thing we need to do is find our LCD just like we did with the problems that were on the board earlier. So with our LCD, we're going to still start with the larger denominator. In this case, what's the larger denominator, folks?
6.
The larger
6.
denominator is 6. So we're going to find that 6 and start taking multiples. The first multiple that 4 goes into, that's our LCD. So we start with 6. Does 4 go into 6?
No.
No. Go to the next one. The next multiple of 6 is?
12.
Does 4 go to 12?
Yes.
Write that down. I will most likely give you partial credit if you write down an LCD. That at least I know you know what you're doing. Okay? If you get the rest of the problem wrong, at least you get maybe 1 or 2 points on this one. You with me? So that's a good thing. Write that down. Now, what we do is we treat this problem like one of these problems I have on the board, one of the equivalent fractions. Here's what I mean by that. What we're trying to get to is 12, both here and here. So you ask yourself, what do I need to multiply by in order to get the 12? What number do I need to multiply 6 by in order to get the 12?
2.
Now, the key about fractions is whatever you do to the denominator,
2.
you have to do the numerator. Otherwise, you change the value of it, and we can't have that. An equivalent fraction means a fraction has the same value. Different denominator, but the same value. So if I multiply the denominator by 2, what else do I have to multiply by 2?
The 1.
Good, which is, what's that called? Yeah, thank you. So if I multiply the 6 by the 2, I got to multiply the 1 by the 2. Let's work on this fraction first. I know I'm going to have plus. What's this fraction going to give me?
2 over 12.
Okay. Hey, real quick. Am I going to try to simplify this stuff? Would that be a good idea?
Not now.
No.
You know what I'm doing? I'm actually purposely unsimplifying. I know that seems weird, but I'm purposely making the fraction bigger than I should. Unsimplify it. Because that's the only way we can find a common denominator. So we're purposely unsimplifying the fraction. That's a weird idea, right? Purposely multiplying by a number to make it look a little bit bigger so that we can add it. So sure, I'm going to have 2 over 12. Whatever you multiply the denominator by, you must multiply the numerator by the same number. So you're looking here, you're trying to figure out how you're going to get 12. This makes 12, right?
Oh, okay.
But remember how on these problems over here, you multiplied by 7 and that's what you had to do to the top as well. Remember that? This dictated what you did up here. This told you what to do here. This is telling you what to do here. Okay, so if you multiply this by 2 to get the 12, you have to multiply this by 2. Necessarily, you have to do that. Now, why it works mathematically, can y'all tell me what is 2 over 2? How much does that equal?
1.
Yeah, so really you're multiplying by 1 in a really fancy way. That's what you're doing. It's not changing the value of the fraction. If you did this, oops, that's supposed to be 1. If you did that, would it change the value of your fraction?
Yes.
Definitely. Yeah, for sure. You're multiplying by 1/2. You would have half the value of your fraction. Can't do that. Whatever you multiply the denominator by, got to do the same thing on that top. Okay? Are you okay with this first fraction off to the right?
Yeah.
Let's work on the next one. Now, again, we're still going to try to get 12 on the denominator. We want to fill out this part now. This is what you're doing. This looks exactly like that now. We're trying to fill out the 12. You just got to tell me what I need to multiply by
3.
in order to get the 12.
3.
Just on the bottom, right?
12.
Oh, okay, both. Because technically, I'm multiplying by 1. I really am. I'm multiplying by 3 over 3. That makes a value of 1. So I'm not changing the value of the fraction. I'm just purposely unsimplifying it for a little bit. So if we have 3 over 3, can you tell me what does this fraction make? What over what? Here's how you check your work to make sure you're doing it right. You should have your LCD in 3 spots. In a little bit, you're going to have it in 4 spots. You should have it up here. You should have it right here and right there. It should all be the same number. So 12, 12, 12. Or whatever your LCD is. How many people feel okay with this so far? After that, well, this is like a problem we've just done in section 4.3. We know exactly how to do that. Next step would be we're going to write this as one fraction. Remember that when we add or subtract fractions, we don't add or subtract the denominators. It's still 12. On the numerator, we get 9 plus 2. We get 11 twelfths. Yes, no? So first step we're doing, we've got to find the LCD. Next thing we're doing is making equivalent fractions like we practiced. Then we can add and subtract like we've done before. Okay, I'm going to model one more for you. I'll give you a couple to do on your own, and I'll be walking around if you guys need help on this stuff. So first thing, what do we need to do? Can we add them the way this is?
No.
We certainly want to do 6 over 20, right? That's not going to be the right answer. We can't just add straight across. Multiply, sure, not add. First thing we do is what then? Okay. LCD. LCD is the lowest common denominator or least common denominator?
15.
We're going to start with the 15, sure. Does 5 go into 15?
Yes.
Hey, you're done. That's great. If 5 goes into that number, then that's automatically your LCD. Now let's start multiplying because we know we're going to have to find an equivalent fraction. Do we need to multiply this number by anything?
No.
If we did, I mean, look, what do you need to multiply by to get 15? Well, we already have 15. We're not going to multiply by 1. Yeah, I mean, that just gives you the same numbers over again. So on this side, we don't have to multiply anything. That's great. It's already done. On the left-hand side, though, we don't have 15 already. You need to tell me what I need to multiply by in order to get 15. On the bottom, on the top, or both? Good. My left fraction, ladies and gentlemen.
6/15.
4/15 we didn't have to change. We know how to add fractions. We don't add the denominators. We just add the numerators. And we're going to get how much?
15.
Am I going to leave it 10/15?
No.
I don't do that. I'll mark you off for that because we should know how to simplify, right? We're past that. So make sure you do simplify these things. We look for any common factors. We know that there's a common factor of what in 10 and 15?
5.
We'll divide 10 by 5 to get how much?
2/3.
Good.
Wait, why did you do that? Why did you do that?
I'm simplifying the fraction. I'm simplifying the fraction. So we need to know that this is, this was one way I showed you how to do it. The other way was, you think about what number goes into both. That number is 5. This is 5 times 2. This is 5 times 3. We cross out the 5s. We get 2/3. Yeah, either way you want to show me at this point, I really don't care. This way is the more mathematical way to do that. Okay, I'd like to try some on your own. Let's do 3 of these things. And then we'll continue. Okay, I've put some variables on these problems and I'm pretty sure you can handle that. Do the same method. So we're finding the LCD first. We use that LCD to make up some equivalent fractions. So you're multiplying both the numerator by and denominator by some number. Then we add and subtract them, and finally we simplify if we can.
Simplify it?
If you can, yeah. Perfect. I'll simplify that. I definitely want to see simplified fractions. Okay, we're back to start on the first one up here. So first example, we have 2 sevenths plus 8 over 21. We're going to start with the biggest denominator. We look at that thing, biggest denominator was 21. We check, does 7 go into 21?
Yeah.
Oh great, that's automatically our LCD right there. So I write LCD is 21. What that means is that my new denominator should be 21 and nothing else. I have 21 already. I don't need to multiply this side. I need 21 over here. What do I need to multiply by to get 21?
3.
Okay. If you multiply the denominator, you also have to multiply the numerator. So my fraction becomes 6 over 21 plus 8 over 21. And lastly, we're going to write this as one fraction because we know we have a common denominator.
14. Do you know how to do that 6 plus 8?
Simplify.
I'd like you to show that, yeah.
Okay.
For right now, as soon as we move past this chapter, no, I don't care. But for right now, I want to see that. How many people made it all the way to 14 over 21? Good. Did you make it past there?
Yeah,
Good. Why?
because it was simplified.
What simplifies out of that?
2/3.
So we'd write this as 7 times 2, 7 times 3. Of course, those 7s, that's what we can simplify out. We get 2/3. Awesome. All right. Next up. We got 2x over 10 plus 3x over 15. Hey, what is your LCD?
30.
Okay, okay. So 30, that means 2 and 3. Did you guys do that? Good, all right, all right. So I'm guessing you did 6x over 30 plus 6x over 30. Yeah?
Yes.
Okay. Cool. So that's 6x plus 6x over 30, or we get 12x over 30. Can you simplify that?
Yeah.
Sure. What goes into that?
3.
6.
Bigger. Take the biggest one you can find.
6.
6 goes into that. Sure. 6 goes into 12, and 6 goes into 30. If you did 3, fine. If you did 2, fine. But you're going to have to do it again. You see that? You have to. You can't just do one round and assume you're done. Double check it. Make sure you've gone all the way you can. That nothing else divides those numbers. Yeah, 6 for sure divides it. So we'd write this as 6 times 2x. We'd write this as 6 times 5. The 6's are gone because we're making a 1 out of that. That's how we simplify. And we get 2x over 5. How many people got that one? Oh, good for you. Can I show you something on this problem? I want you to see something. When you're adding and subtracting fractions, there's nothing that says you can't simplify first. Okay, now, of course, we wouldn't want to simplify here because we purposely unsimplified. But check this out. If I start with my 2x over 10 plus 3x over 15, do you guys see that I could simplify this one immediately?
Mm-hmm.
That's actually x over 5. Do you see it?
Yeah.
Divide both the top and bottom by 2, you get x over 5.
And the 3.
This actually you can simplify. 3 goes into that.
Yep.
That's x over 5. Do you see that? Yes, no. If you don't, shake your
Yes.
head, that's fine. Yes or no? Okay. So in our case up here, we do, remember that 2x, we could write 2 times x. 10 would be 2 times 5, yeah?
Yes.
This would be 3 times x. This would be 3 times 5. Every time you have matching factors, they're gone. X over 5 plus, oh, wait a second. How about that? X over 5 over x, do we already have a common denominator? This would be, I'm going to erase this so I don't get confused here. This would be x plus x over 5. Numerator's being added. Denominator just stays the same. How much is x plus x?
2x.
Did you get the same answer?
Yes.
Sure. There's nothing that says you can't simplify first. So if you want to save yourself some time at some points, try simplifying first. That's okay. You can do that.
Is
Okay?
x squared the same thing as
2x and x squared are not the same thing. X squared means x times x. 2x means x plus x. Good question. Do you guys see the difference between these problems? I hope so. Okay, what was the last one I did?
5y over 6
Over 6, 2y.
over 9 plus 2y over 9.
I got.
Yes.
Let's find an LCD. We'll start with the biggest denominator, that's 9. 6 doesn't go into 9. We check 18. Does 6 go into 18?
Yeah.
18's are LCD. We've got to multiply both these fractions. So on the right-hand side, tell me what I multiply by, please.
2.
On both the top and the bottom. Left-hand
3.
side, how much?
3.
We're going to get 15y over 18. We're going to get 4y over 18. I do want to see the next step. I do want to see 15y plus 4y over 18. The reason is because when we get to negatives in about 5 seconds, this is going to help you out a lot, especially when we have more than 2 fractions. We're going to have 3, 4, 5, 6 fractions with order of operations stuff. If we don't show these steps, it gets kind of messy. Doing it in your head, you're going to make sign errors. Trust me on that. That's why I'm going to make you show this step. We have 15y plus 4y. That gives you...
19y over 18.
I was hoping for more enthusiasm, guys. Come on, you let me down. Hey. Yeah, 19y over 18, exactly. Can you simplify 19y over 18?
Yes.
Make it mix up.
Right, that into the next fraction? And mix it, right?
Yeah, you could if you wanted to. It'd be 1 and 1/18 y. Okay, you could do that. Do you have to do that? No. Simplified means no common factors. These don't have any common factors. 19 is a prime number, so there's no way we can simplify it. You could write it as a mixed number. That's a difference, right? So if I'm not asking you for a mixed number, that's fine. If I am, then you have to go one more step. How many people feel pretty good about finding LCD so far? How about the equivalent fraction thing that we practiced?
Yeah.
And can you use that to now add some fractions?
Yes.
Okay. Next time we're going to start subtracting fractions. I'll show you some negatives, what to do with that. We'll deal with multiple fractions at a time, so more than just 2. And then at the very end, we'll start doing some complex fractions and order of operations. That'll be a good day. So we're adding and subtracting some fractions, and what we need to understand is that we can do this even with some negative fractions. So let's take a look at a few examples to illustrate how we deal with a negative fraction in this instance. So for example, what if we do negative 1/5 plus 9 over 20? Okay, ladies and gentlemen, what do you have to absolutely have in order to add or subtract fractions? Good. Do we have one so far? Okay. Hey, before you get started, let me do you a favor here and tell you something that works with fractions every time. If you have a negative fraction, notice on our first fraction how we have negative 1/5. In order to make your fractions easier, do this. Whenever you have a negative, take that negative. Do you remember me telling you that it doesn't really matter where the negative goes? Go in front, go in the denominator, or go in the numerator. Do you remember that?
Yeah.
Take that negative and put it on the top of your fraction, on the numerator. Because what that's going to do is allow your denominators to be exactly the same sign. That makes it easier. And it allows you in the next step to use addition rule appropriately. Otherwise, out front, it's kind of hard to deal with this. I don't want you adding these two numbers. You're not going to get 10 out of this. You're going to get 8 somehow. And how you're going to see that is with that negative going up to that 1. So right off the bat, if you have a negative fraction, take that fraction, make it a negative on the numerator. Associate that negative with that numerator.
Always do that.
Always do that. If it's a negative, yeah, always do that. Makes things a lot easier. Now, next up, we got to find an LCD. Can you tell me what's the LCD for this problem?
20.
Good, yeah, very good. We'd find the biggest denominator. We check to see if the other one goes into it. It does. So we'll write LCD is 20. Okay, folks, what do I need to multiply this fraction by right here?
4.
This one.
Five.
By 1. No.
By anything?
By 1.
No.
If I multiply by 1, am I going to change it?
No.
So do I need to multiply by anything?
No.
Okay, no problem. Sometimes that happens. How about the one on the left-hand side? Notice, hey, this is why we did this. It's why we moved the negative to the top. Now I'm able to multiply by just a couple numbers, and I just have that negative on the top. That's kind of nice. It helps out a lot. What do I need to multiply that fraction by on the left-hand side?
4.
Now that that negative's on the numerator, we can do 4 times negative 1 and get how much?
Negative 4.
So negative 4 over what?
20.
Plus 9 over 20. We've got a common denominator. Now look what happens. When we make our one fraction out of this, which of course I'm asking you to do, we are going to get 20 on the denominator. The denominator does not change. But on the numerator, what are we going to have?
5.
Negative 4 plus 9.
Oh, I said 8. I meant 5. Yeah, we're going to have negative 4 plus 9.
That's the answer?
No, not yet. Well, I definitely want you to show that step, especially when we start dealing with more than one fraction at a time. This helps out a lot. Can you add negative 4 plus 9 now?
Yes.
That's addition rule. Addition rule says different signs, subtract, sign the bigger number. How much do we get out of that?
5.
This is why we keep that negative on the top of our fraction. Notice how it's followed that 4 all the way down. That's kind of nice. It lets you use your addition rules like you have before. If we keep it out front, it makes things a little bit harder. And are we going to leave it 5 over 20?
No.
Heck no. No, we want to simplify those things. So 5 over 20 gives you...
4.
Cool deal. We divide the top and the bottom by 5, or put 5 times 1 over 5 times 4, cross those 5s out, we get 1 4. We're going to do 2 more together. I'll give you a couple to do on your own, then we'll move on. Hey, do I need a common denominator even though I'm subtracting?
Yes.
Yeah, absolutely. Can you go ahead, don't say it out loud, just do it in your head. On your own, find your LCD here, on your own. Take your bigger denominator, start finding multiples. The first one that 3 goes into, that's your LCD. What is your LCD here?
33.
Good. So we'll write that down. And we remember that we're trying to find equivalent fractions here. So we're going to multiply by an appropriate number on both the numerator and the denominator. That keeps it equal to the same value. We're not changing the value of the fraction, we're just changing the way it looks. We're purposely unsimplifying these things. So on the right fraction, what are we multiplying by? What was that?
By 3.
Just 3 or 3 over 3?
3 over 3.
Okay.
Do we have to show that?
Absolutely.
It's confusing.
Sorry. But I absolutely do need to see that, yes. On the left fraction, we're going to multiply by what?
11.
Yeah. What we're doing here is we're technically multiplying by 1. We just have to show this work because I need you to see where the next fraction is coming from. So we're multiplying by 3 over 3 and 11 over 11. We really are multiplying by 1. Do you guys see it? This is 1, and that's 1. So we're not changing the value, we're changing the way it looks. So we multiply by whatever number it takes to make 33. So here it's 3, here it's 11. We just have to do the same thing to the numerator as well. Can you tell me what this fraction is going to become, please?
22 over 33.
We still have a minus sign. How about the other fraction?
30.
How can you check your work?
Subtracting.
How can you check your work? Not subtract, we're not there yet.
Simplify the.
Yeah, you could. You could simplify this in your head. This should give you 2/3. This should give you 10/11ths. And it does. It does. So you can try that. Also, you need to make sure that this LCD appears in both of your fractions. That's what it should be. After that, we've got what?
22 minus 30 over 32.
Good. Yeah, I want to see that step. We're learning this stuff. I need to see that. So 22 minus 30 on the top. And then on the denominator, how much are we going to have?
33.
Hey, how much is 22 minus 30? 8 or negative 8?
Negative 8.
Yeah, remember that you could use addition rule here, right? Change that into plus and negative. If you want to show that, that's fine. If you don't want to show that, that's okay too. If you can do 22 minus 30 at this point and get negative 8, that's fine with me. For those of you who need that, you could do 22 plus negative 8. Shoot, that's the answer. 22 plus negative 30 over 33. Then you would get the negative 8 over 33. Hey, can you simplify negative 8 over 33?
No.
But you should check for it. But we can't in this case. Last one we'll do together before we get some on your own here. We're going to look at 5/8 minus 1/3 minus 1/12. Now we got more than two fractions, but it's still possible if we go ahead and do the same exact thing we've been working with. So what we're going to try to do is firstly, find a common denominator. You absolutely have to have that. In this case, which denominator are we going to start with when we're finding our multiples?
12.
12, definitely 12. So we'll start with 12. Does 8 and 3 go into 12?
No.
Well, 3 does, but 8 doesn't. You got to find one where they all go into that number. So we can't do 12. We try 24. I know 12 goes into it because that's how we're getting those numbers in the first place. Does 8 go into 24?
Yes.
Does 3 go into 24?
Yes.
So that would be our LCD. Now instead of just two fractions, we're going to multiply all three fractions by some number. Let's start with the 12. Remember, what we're doing is we're trying to get 24 on the denominator of our fraction. Can you tell me, folks, if I have a 12 down here, what number do I need to multiply by to get a 24?
2.
I can't just multiply the denominator by that. I also have to multiply the numerator. Let's go over here on the 8. Can you tell me, I have a denominator of 8, I want a denominator of 24.
3.
What do I need to multiply by? And that's got to be both on the top and the bottom, the numerator and denominator. Now, Jeff, if you're still okay with it so far. Yes? Guys in the back? Okay. How about the middle fraction? Do I need to multiply that one as well?
Yes.
Yeah, otherwise, I'm going to have a denominator of 3. I don't want that. I want a denominator of 24. I'm going to make some room here. So I want to get 24. What's the magic number in this case?
8.
Yeah, we got to do 8 on both the top and the bottom. Hey, let's figure out what these fractions are. We got 3 over 3 times 5 over 8. How much is this fraction going to be when we're all done?
15 over 4.
Cool. Then we have a minus sign because we had a minus sign up here. We have 8 over 8 times 1 over 3. How much are we going to get there?
8 over 24.
Good. And lastly, we've got 1/12 times 2 over 2. That's going to give us 2 over 24. Hey, by show of hands, how many people think they can make it that far? Good, all right. Now that we have a common denominator, we can write this as one fraction. Of course, our denominator is not going to change. We're still going to have that 24. On the numerator, what you do is you simply write every numerator along with the sign. So we're going to have, what are we going to have?
15 minus 8 minus 2.
Good, minus 2.
Equals 5.
What this does for us when we write this as one fraction, I want you to see it. It changes a fraction problem into actually just a subtraction problem. We've done problems like that before in this class, right? So as long as we're writing this, doing the process I'm making you do here, it's going to make things a little bit easier for you. Instead of thinking of the full fractions, now you just have to think of the numerators, and that's nice. That way you can use addition rules. You can change those to plus negatives, change that to a plus negative, use addition rule on that and figure out your answer. Or if you like subtraction, just do the 15 minus 8 minus 2. How much is 15 minus 8?
5.
Okay, 15 minus 8 is 7.
Seven.
And then minus
Oh,
2
yeah.
is?
5.
Okay. 5 over 24. You jumped the gun.
She's just one step ahead.
Just one though. Just one. 5/24, can I simplify or reduce 5/24?
No.
Then you are done. Are you with me on this one, guys?
Yes.
Okay. I'm going to give you 3 to 2 on your own. Follow these steps. Make sure that you are writing this as one fraction before you do the math on that. I need to see that. So in our process here, we find our LCD. We definitely have to have that. Write these equivalent fractions. So we're changing our fractions here to have a common denominator, putting them as one fraction, and then doing either addition or subtraction. That's our goal. Take about 1 more minute here, and then we'll get started on the board. Okay, so let's look at number 1. We got negative 1/6 plus 1/2. There's one thing I told you to do with that negative. What did y'all do with that negative? I hope you did.
Put it on top. Put it on top.
Yes, put it on top. That allows you in the next few steps to keep that negative on the numerator. That way when you add or subtract it, it's easier. It's not up front, you have to worry about it. So then we're going to find our LCD. Our LCD in our case is how much?
12.
Really?
No, 6.
6.
Yeah, just keep it 6. Shoot, 2 already goes into 6, may as well. Don't do any more work than you have to. Check the denominator itself first. 2 goes into 6, keep it 6. Folks, do I need to multiply this fraction by anything?
No.
How about this fraction?
Yes.
So we're going to get negative 1/6, that's from here, plus 3/6. We're going to write this as one fraction first. Our denominator is 6, we have negative 1 plus 3. What's negative 1 plus 3?
2.
2.
And 2/6 gives us
1/3.
You get 1/3 out of that. Remember how we're simplifying? We're doing 2 times 1 over 2 times 3. Whenever you have those common factors, you cross them out and you get 1/3.
I use 12 and instead of 1/3.
Oh, yeah.
You will. You will.
Can you do that?
Stop. Listen. You can use, you ready? You can use what? Let me have your attention. You can use whatever number you want. You can use 12, you can use 24, you can use 48, you can use 36, you can use 120, use 126, you use 600, use whatever you want. What's going to be the easiest? 6. Yeah, you can use any number that you want. You are just making extra work for yourself if you don't pick the smallest common denominator. Are you with me? So you pick 12, sure, but you had to multiply both fractions, I didn't. Are you going to get the same answer? Absolutely. Yeah. This math stuff, it works all the time the same way. As long as you have a common denominator, you're going to be able to solve this problem. It's just going to require you to simplify more at the very end. Are you with me on that? Okay, so that's why we look for the least common denominator, not the greatest. We don't want the biggest numbers up there, we want the smallest numbers. That's why. So will it work every time if you find a different common denominator than me? Yeah, probably if you do your math right. But it's going to be easiest if you stick with the LCD, the lowest common denominator. Oh yeah, okay, next one. So we have 5/7 minus 9/10. We need an LCD. Did you find your LCD?
470.
70, that's right. Yeah, this time they have no common factors. If they don't have any common factors, you know your LCD is going to be the product of those two numbers. We multiply here by 7 over 7. Multiply here by 10 over 10. So I'm hoping that you got 50 over 70 minus 63 over 70. Did you make it that far?
Yeah.
Show me one more step. Let's go ahead and write this as one fraction. We'll have something over 70, and this number is going to be 50 minus 63. Change that to a plus negative if you want to use the addition rule, or do the subtraction directly. I don't care at this point either way. If you do 50 minus 63, though, in either case, you have to be able to get the right answer out of this. Don't give me positive 13. Don't give me something like that. Certainly don't give me something like 113. Give me the correct answer of how much?
Negative 13.
Negative, good. Negative 13 over 70. And that's appropriate. How many people got negative 13 over 70? Good for you. That's fantastic. Okay, last one that we're going to do together before we move on. We have 3 fractions now. Did I do that? I need to change my problem here. I wrote the wrong thing on the board. Can I change it?
No.
Ah, whatever. We'll just do this one. We'll do both. Now let's do this one. It'll be the same thing. So, common denominator. What is our common denominator here?
14.
Clearly 14. That was supposed to be a 4. I actually didn't put the little 1 there. So that made things way easier for you. That's okay. If that was a 4, if this was a 4, let's just do that. If that was a 4, would your LCD change?
Yes.
Yeah.
What would your LCD be then?
28.
Good, that would be 28. It's not, it's 14, I'll keep it 14, that way I don't mess everybody up, sorry, my bad. And we'll go ahead and find the LCD, well, it's 14. We'll find what the fractions are. Do we need to multiply this fraction by anything?
No.
This fraction?
No.
This fraction?
Yes.
Times?
2.
What are we going to do to this fraction?
Stay. Put the
minus
negative
by the
on top.
numerator.
Good. That allows you, when you make one fraction out of it, to have a negative on the top instead of a negative up front. That way you don't forget that that's actually a negative 3, not a positive 3. That's where people make a mistake. So we're going to have negative 3 over 14 minus 1 over 14 plus 12 over 14
Make it 1 5.
we're certainly going to make that one fraction. On the numerator, we're going to have, this is why I moved the negative up, negative 3 minus 1 plus 12. Did you make it that far?
Yes.
Good deal. We do our math. We know that negative 3, how much is negative 3 minus 1? Negative 4, very good. If it takes you the transition to make that addition rule, that's fine. You can certainly do negative 3 plus negative 1 plus 12. That's fine. You can do that still. If you do the negative 3 plus negative 1, that was going to give you the negative 4. And the negative 4 plus 12, you should be getting 8 out of that. Did you get 8?
Yes.
And we're going to leave it 8 over 14, right?
No. 4 7.
4 seconds. Simplify both by a factor of 2, we get 4 sevenths. Hey, would you raise your hand and feel okay with this, what we're talking about so far? Good, okay. Hey, what do you do if you're asked to subtract a whole number minus a fraction? Can you do it?
Yes.
Change it to a fraction.
Put a 1.
What do you mean add a 1?
Put a 1 underneath the 5.
Change it to a fraction.
Okay, change it to a fraction by,
Adding 1.
okay,
Make
put a
it
1.
one to the denominator.
Sure, we know that 5 is the same thing as 5 divided by 1. So we could do 5 over 1. And if we do that, then we change a whole number into a fraction, or anything that we want into a fraction, just by putting it over 1. After that, we're home free. We've got to find an LCD, multiply appropriately, and then we'll be able to combine these. So first question, can you find the LCD between 1 and, what was that, 3? 1 and 3.
3.
So LCD is 3. Do I need to multiply one fraction or both fractions?
Both.
One.
Just 1.
Oh, 1.
I've already got the 3 in one spot, right?
Just 1.
So I don't need to multiply this one. I've already got the 3. Don't worry about that. I do need to multiply this fraction. What do I need to multiply that by?
3.
3 over 3.
First fraction is going to become how much?
15 over 3.
Minus this fraction didn't change at all. That fraction. Now we have 15 thirds minus y over 3. Okay. What's our denominator going to be?
3.
Can you tell me what's going to be on my numerator?
15 minus y.
Good. All this practice making one fraction kind of pays off a little bit because now, well, can you subtract them?
No.
Is that going to be 14y?
No.
15y?
15.
Let me ask you this.
terms.
Are they like terms?
No.
Can you combine terms if they're not like terms?
No.
Then you're done. Yeah, that's it. I think you guys are ready for this. Let's try one more. Okay, let's focus on the board. We've got 3/4 minus 5 over x. We got 3/4 minus 5 over x. What do you need in order to add or subtract fractions?
Common denominator.
Not like terms. What was it?
Common
LCD.
denominator.
Does it have a common denominator right now?
No.
Okay. We got to find out what our LCD is in this case. Now, if you don't have, let's see if I have an example here. If you don't have a common factor, what we knew is that our LCD was a product of our denominators. If we have 4 and x, there's nothing in common between 4 and x. We don't even know what x is right now. So in order to find our common denominator, we go, oh, okay, if they don't have any shared factors, which they don't, I know that the LCD is simply the product of those two denominators. In our case, that's going to be 4 and x. It's got to have both those factors up there. Are you okay with that one?
Yeah.
That's the only way we're going to have a
You
common
just have to
denominator.
times that by x, times that by that.
We do, because they're not sharing any factors, we're multiplying those denominators, yeah.
So, the 3/4 we have to multiply by x.
Well, we're going to find out right now, yeah. See, we want 4x on the bottom, right?
Yeah.
I don't have 4x on the bottom here, and I don't have 4x on the bottom here. Let's work on this fraction first. I have x, I want 4x. I have x, I want 4x. What do you need to multiply by to get 4x?
4.
4.
Sure, yeah. Is 4 times x equal to 4x?
Yeah.
Okay, make sure it's on both the top and the bottom. Now let's look over here. I've got 4, I want 4x. What am I missing?
X.
Multiply by x. Is x times 4 equal to 4x? Am I going to get that 4x that I want?
Yeah.
Okay. As long as you do both the top and the bottom, you're okay on this problem. Let's see what this is. This x over x times 3/4. How much is that going to give me?
We have to.
3x over 4x.
Good. You sticking with it?
Yeah.
Okay. We still have a minus sign. How much is this fraction going to give me?
20 over 4.
20 over 4x.
Good. Do I have a common denominator like I thought?
Yes.
Sure, so that worked out. So we're going to put this together as one fraction. Of course, we're going to have 4x on the denominator. On the numerator, I'm going to have...
3x minus 20.
Now, I have one very important question to ask you. I actually don't even want you to answer it. I just want you to think the answer in your head. I'm going to ask you a different question that's going to clarify whether you're right or wrong, okay? Don't answer out loud. Can you cross out the x with the x?
Yeah.
I said don't answer out loud. I would be following directions. Don't answer out loud. Can you cross out the x with the x? You see, I didn't want you to answer because I need to explain one more thing to you. The only time we're ever allowed to simplify, I hope some of you are listening out there, the only time you're ever supposed to simplify or allowed to simplify is if you are multiplying everything together. That would mean, sure, that's multiplication. Is that multiplication?
No.
The only time you're ever allowed to simplify is if you're multiplying everything together. That was the rule. That's it. So I'm going to ask you again, can I simplify this x with this x? Definitely not. Not unless everything is multiplied together can you simplify. See, I still have a lot of people in Math C, that's 2 levels from now, who look at this problem and will cross out the x. They're not going to pass my class. They're not. Because they do that mistake all the time. What's happened is by that level, if you're doing this, you're practicing a bad mistake over and over. If you've ever played sports, your coach, you ever played baseball?
Yeah.
You ever even swung a bat before? Probably everybody has. If you've ever played baseball, then you know that a swing is pretty important to your success, right? You have to have a good swing. And your coach will really hammer you if you have a bad swing. Because what happens is if you practice that swing over and over and over again, it becomes natural to you, right? It's very hard to break a habit that becomes natural to you. Do you agree? Very hard to break that habit. And so your coach will hammer at you because he wants you to break that habit to get a correct swing. This is a poor swing right here, doing this mistake over and over again. And once you get to Math C, if you've done it so many times, it's natural for you to do it. I'm hammering you now. I have to make sure that you do not do this. Are you seeing the analogy? Okay, don't make that mistake and cross those out. The only time you ever can is if it would have been like this. Look, this is a different problem. Completely different. Now that those are multiplied, yes, absolutely, those are factors. I can simplify factors. I cannot simplify terms. There's a difference here. As soon as that's connected to that subtraction, you can't cross it out. If it's being multiplied, absolutely. Nope.
What about if there was a 4 in the x, would you be able to simplify with the 20?
Like that.
Yeah.
Here you could not.
No, and the other.
Right. Here, definitely you could. Okay. Here, since we're multiplying everything, you can. The reason why this works is you can separate those fractions out. Get your x over x times the rest of it. You get your 20 over 4 times the rest of it. You can't do that here. It's different. Different problem. Do you see the difference between those?
Yeah.
Are you sure?
So I can separate by example.
That's it. You cannot do anything more with that. This one, if it had been multiplication, yeah, we do a lot more with that. But it's not.
If it's addition, you don't do it either.
Yeah. Plus or minus. Yeah. Either one. Did that make sense to you? That was kind of a big deal. I needed you all to focus on that, that's why I waited for you.
That one was kind of like that one you just did, only that it only has one.
Yeah,
letter.
real similar, right? Because, I mean, can you simplify the 15 and the 3 here?
No.
No.
Look at the board with
Yeah.
me.
You can.
Can you simplify the 15 and the 3?
Yes.
Are you sure?
No, because it's subtracting. They're multiplying.
Okay, I need to see the similarity here.
No, but if it was multiplication, you could.
Can you simplify the x's?
No.
No. Can you simplify the 4 with the 20? No. Can you simplify the 3 with the 15? No. It's being subtracted. Look at this similarity. Subtraction, I can't simplify that stuff. I can't simplify that stuff. Unless it's multiplication, you cannot simplify it.
For addition, it goes the same thing too, right?
Whether this is
If it
a
was
plus
a-
or a minus,
Okay.
right. The only time you can ever simplify is if you have multiplication. Not if you understand that. Okay, so can I simplify the 15 and the 3?
No.
No. How about the x and x? 4 and the 20? No. None of that stuff. Try one more on your own, okay?
Oh, I have one question.
Sure.
What if you only had 3 minus 20 and then a 4, like 4x or whatever, but like the number that
Yeah.
was left over, you could reduce it. But so you wouldn't reduce it if the bottom number has the letter.
Let me see if I can make up something where I
Okay,
think
well,
you're trying to
well,
say, like
let me
this,
just tell you
okay?
just an example. Like, how about if it's just 2 and 6x in the bottom? Can you simplify that, or you just leave it like that?
How about this, okay? How about this one? I think this is going to answer your question. Firstly, there's no x up here, right? Let's pretend we got down to this far. It's like some
Yeah.
imaginary problem.
Yeah.
We got down to here. Can you do 4 minus 20?
Yeah.
Of course, yeah. Don't forget you know how to subtract. How much is that going to be? Negatives over 8x. Do you agree?
Yes.
This for sure you can simplify. Absolutely. This is a number over a number times a number. Okay, is this answering your question?
Yeah.
In this case, you go, okay, what number goes into both negative 16 and 8?
8.
Think bigger than 2. We got
8.
8. 8 goes into this negative 2 times. 8 goes into this 1 time. Your answer is negative 2 over x. That's it.
So it's only that way.
You're definitely going to be doing this. A lot. Yeah, all the time. For the next 2 classes you have, do this a lot. Okay. Did this make sense to you?
Yeah.
So yeah, you need to know when you can simplify and when you can't. If you have something, pay close attention up here, okay? If you have something that's connected with addition or subtraction that you cannot combine, like this, like that, you can't simplify any part of it. If you have something that's connected with addition, subtraction, and you can combine it, then perhaps you can simplify it. But until you get one number over one number, or multiplying over multiplying, you cannot touch it with simplification. You can't cross anything out. That's the whole deal. Try that one on your own, okay? We'll deal with those ones in just a bit. Okay, 2 minus x over 3. First thing we're going to try to do is make this thing at least into a fraction. How do we make 2 into a fraction?
Over 1.
Awesome. Next thing we got to do is find an LCD. What is your LCD for that problem?
3.
So we're going to have, LCD is 3. I don't need to multiply this one by anything because I already got the 3. However, here I need to multiply by 3 over 3. So I should be getting 6 over 3, which, by the way, you can check your work, right? Is 6 over 3 still equal to 2?
Yeah.
Sure. You do it as you go. Minus x over 3. You're going to make this one fraction. You already have the common denominator. That's great. You're going to get 6 minus x over 3. How many people made it that far? Good deal. Now, the question for you, guys in the back, did you make it that far? The question I have for you, can you simplify the 6 and the 3? Yes or no?
Yeah.
No.
No.
You got to know this.
No.
Yeah.
No, you can't.
It's not.
No, it's not multiplication.
Good. Unless it was multiplication, I can't simplify it. Did you not simplify it, I hope? Hope you just left it just like that.
Yeah.
Good. If it had been multiplication, then yes, you could. Would you raise your hand feel okay with what we just talked about so far? Hey, now how do we find out whether a fraction is bigger than another fraction or not? For instance, if I look at 5/8 and 11/12, can you immediately see which one's bigger?
Yeah.
20.
Yeah.
20 is bigger?
Yeah.
Okay, so you're saying that this one's bigger than this one?
No.
Or this one's
5/8
bigger?
is
Or are
bigger.
they equal? Are they equal?
No.
Yeah, because they're both half plus
I don't
one.
know. How do you find out? Well, here's the thing. If these things had the same denominator, would you be able to tell?
Yeah.
Yes.
Easily.
It's always when
Make them the same denominator. If you have the same denominator, yeah, then that's easy. But right here, I mean, a lot of you just said this number's bigger than this number. Well, let's find out, because right now you're guessing, and you don't know. So if you know how to find out whether a fraction is bigger if the denominators are the same, make the denominators the same. Go ahead and do that right now. It's just like adding or subtracting fractions, except we're not adding or subtracting them. Could you find your LCD out?
Yes.
40, very good. So we tried 20, 20 doesn't work. Try the next one, 40. This 2 over 2. This 5 over 5. You get 25 over 40.
So 25.
You get 22 over 40.
So 5/8 is bigger, no?
I don't know. You tell me. What's bigger, 25 40ths or 22 40ths? 22 40 is bigger than 25 40ths?
No, 25 over 20.
So 5/8 is bigger.
Hey, if you have the same denominator, what number is bigger, 25 or 22?
25.
Definitely 25. That means that this is bigger. That means that this is bigger. 5/8 is bigger than 11/20. And that's how you tell. You find a common denominator, and then automatically you just look at the numerators of those numbers. Whatever one's bigger, that tells you what original fraction is bigger. Nudge your heavier with me on that one.
Yep.
Okay, let's try the next one. Let's do -2/7 and -1/3. Firstly, what are we going to do with those negatives?
Put them on top.
Numerator.
Do that. Can you tell me the LCD for 7 and 3? Because right now I'm having a real hard time thinking in my head which is bigger, -2/7 or -1/3. That's kind of difficult, especially with those negatives. I don't know. But what's our LCD then?
21.
I don't know. We'll find out right now. Multiply by 7 over 7. We'll multiply by 3 over 3. So we'll get -6 over 21. We'll get -7 over 21. Are you seeing where we're getting the -6 and the -7 over 21s? Okay, what number is bigger? Now that we got 21, this, by the way, this is why we kept the negatives on the numerator, so that we could just ignore these. What's bigger, -6, -7?
-6.
So this fraction is bigger. That means this fraction is bigger. -2/7 is bigger than -1/3. You feel good about it?
Yes.
Okay with it? All right. Yeah,
We have so that can be said.
probably. Can you be okay with that?
Yeah.
All right. Would you like just like 20 problems like that?
Yeah.
I know, right? Be nice.